Hey guys, this is a lesson on section 4.8, solving equations containing fractions. This is my cat Max, for those of you who are wondering. He likes to run up here right in the middle of my lectures. So if you see that tail walking back and forth, that's him. Okay, so we're going to be doing probably everyone's most hated section in the whole book, solving equations containing fractions. Now fractions are, we've already dealt with them, but now we're actually going to be dealing with equations. So equations means that they have the equal symbol. And there's a lot of different kinds of equations with fractions. The first few ones are easy, but then a lot of the later ones are pretty difficult. So I'm going to try to give you as many examples as possible. Okay, so let's start with some easy ones to build our confidence up. Okay, so number one. Alright, my cat is getting in the way. Let me pause this. Okay, so the instructions here are solve each equation. Solve each equation. Okay, and for problem number one, we're going to be doing x plus 1/7 equals negative 1/7. X plus 1/7 equals negative 1/7. Now with this one, notice that all the fractions already have the same denominator. So the easiest way to do this is to just get rid of this 1/7 on the left side to isolate x. So this one's actually pretty easy. All we have to do is get rid of this positive 1/7. And what's the opposite of adding 1/7? Subtracting 1/7. So if we minus 1/7 from both sides, then on the left side we're just going to have x. And on the right side, because these are like fractions, and they're both the same sign, we keep the sign and add. Okay, so we're going to be adding 1 plus 1 is 2, but we're keeping the sign, which is negative, so we're going to get negative 2/7. So again, what we're doing there is, because the denominators are the same, they're like fractions, we're keeping the denominator, and then we're adding or subtracting the numerators. Right? And that's actually the whole problem. And you can check these if you want to. The easy ones are pretty easy to check. The hard ones are difficult to check. But I won't check most of them. I'll just check this first one to show you how to do it. Okay, so check. Basically, the way you check is you plug in the answer you got into the original equation, and then you make sure it's true. So to check here, we would have plugging in for x, we would be plugging in negative 2/7. Okay, so our equation would be negative 2/7 plus 1/7 equals negative 1/7. Okay, and we can see that this is true because these are like fractions. So we do negative 2 plus 1 on the top, and that gives us negative 1/7. So this checks out. Okay, but again, I'm not going to be checking most of them. It's up to you whether you want to check them. Some of them can be a pain to check, so that's why I don't usually check them. If you want to check them the best way to do it is probably to just read through your work and make sure each step is correct. Okay, so that's number one. That's a relatively simple equation. And any of the equations where they all have the same denominator shouldn't be too hard. Okay, so let's take a look at number two. Example number 2. For this one, we have 5x minus 1/5 minus 4x equals 1/5 plus 2/5. Now, even though this one looks a lot more complicated than the last one, it's actually also an easy problem, because notice that all the fractions have exactly the same denominator. So these are all like fractions, which means all we have to do is combine the fractions, and then we have to isolate the variable. Okay, so like here, on the left side, we can combine like terms. So on the left side, we have 5x minus 4x, and we know that 5 minus 4 is 1. So that's just going to give us x minus 1/5 on the left side. And then on the right side, 1/5 plus 2/5, because they have the same denominator, we keep the denominator and we add the numerators. So 1 plus 2 is 3/5. Okay, so the like terms on the right side were 1/5 and 2/5. Okay? And then how do we finish the problem? Well, since these have the same denominator, we just need to isolate x on the left side. So what's the opposite of subtracting 1/5? Adding 1/5. So to get rid of this negative 1/5, we're going to add 1/5 to both sides. Okay? So if I add 1/5 to both sides, then on the left side I just have x. And on the right side, since they're like fractions, we keep the denominator and add the numerators. So 3 plus 1 is 4/5, or 4/5. So x equals 4/5 is our answer. And again, you could check this, but as you can see, you'd have to plug in 4/5 here, and it would be very complicated looking, and you'd have to add and subtract a bunch of fractions. So that's a lot of extra work to check these. If you want to do it, you can, but it takes a lot of time. Okay? All right. So those were relatively easy problems because they're like fractions. So hopefully those are not too challenging. Now for problem number 3, we're going to see some fractions that are unlike fractions. So they have different denominators. So for this one, we have x minus 1/36 equals 17/18. X minus 1/36 equals 17/18. So what we want to do is we want to isolate x, but these two fractions have different denominators. So what we're going to have to do is build all fractions to a common denominator. And what most people build it to is the LCD. You don't have to build it to the LCD, but it's usually the easiest one to build it to. Okay, so I'll put LCD in parentheses. So what's the LCD of 18 and 36? Well, you take the bigger number, which is 36, and you list all the multiples of it until you find a multiple that 18 goes into. But just the first multiple of 36 is 36, and we know that 18 times 2 is 36. So here, the LCD is 36. Okay, and then we need to multiply each of these fractions by what we're missing until we have them built to the LCD. So this one we already have 36, so we're good. This one, what are we missing? Well, we're missing a 2 because 18 times 2 is 36. So we're going to multiply this second fraction on the right side by 2 on the top and the bottom. Okay, so what's that going to give us? Now we're going to end up with x minus 1/36 equals 2 times 17 is 34/36. All right, and now these are like fractions, so now this problem is just like the last problem. Okay, so the rest of it shouldn't be too bad. So all we have to do now is isolate x. So the way we're going to do that is, well, the opposite of subtracting 1 over 36 is adding 1 over 36. So we're going to add 1 over 36 to each side. Okay? Alright, so we get x equals, well, on the right side, 34 plus 1 is 35 over 36. Alright, and these don't have any common factors because 7 times 5 is 35 and 6 times 6 is 36. So there's no common factors. So 35 over 36 is our answer. Okay, so that one's a little bit harder, but still supposed to be a relatively easy problem. So hopefully it's not too bad. Okay, so I'm just going to be doing gradually harder and harder problems to make sure you see each type of challenge that shows up. Okay, so that was number 3 that we just did. Now we're doing number 4. Number 4 is negative 1/16 equals x minus 7 over 12. Negative 1/16 equals x minus 7 over 12. So now here, this one's a bit harder, mostly because it's harder to find the LCD of 16 and 12. But because these are different denominators, we do need to find the LCD. Okay, and again, probably the easiest way to find the LCD is to just pick the larger denominator, which here is 16, and then you start listing multiples of it until you find one that the smaller denominator goes into. Okay, so if we start with 16, we know that 12 does not go into 16, so we cross it out and we go to the next multiple, which is 32. Does 12 go into 32? No. So 12 does not go into 32, so we go to the next multiple, which is 48. Does 12 go into 48? Yes, it does, because 12 times 4 is 48. Right, so the LCD is 48. Okay, and then we need to multiply each of these fractions on the top and the bottom by what we're missing. Okay, so for the negative 1/16, we know that 16 times 3 is 48, so here we're missing a 3. So we're going to multiply this fraction on the left side by 3 on the top and the bottom. And then on the right side, we know that 12 times 4 is 48. So we're going to multiply the fraction on the right side by 4 on the top and the bottom. Okay, so after we do all that, our new equation is going to be negative 3 over 48 equals x minus 7 times 4 is 28 over 48. Okay, so we have negative 3 over 48 equals x minus 28 over 48. Okay, and then now these are like fractions. So since they're like fractions, the rest of the problem is pretty easy. Okay, so now what we do is we want to isolate x on the right side, so we need to get rid of the negative 28 over 48. And how do you get rid of a minus? Well, you add the same number. So we're going to add 28 over 48 to both sides. Okay, so add 28 over 48 to both sides. Okay, so on the left side, we know that 28 minus 3 is 25. So we get 25 over 48. And then on the right side, we're just left with x. Okay, so we have 25 over 48. Can we simplify this? No. Because remember from your times tables, 5 times 5 is 25. And then for 48, 12 times 4 is 48, but there aren't any 5s in there. So 5 does not go into 48. So that means 25 over 48 is our answer. Okay? Okay, cool. So that was problem number 4. Okay, and let's take a look at problem number 5. Problem number 5 is negative 25 equals 5 over 17 times x. Okay? Negative 25 equals 5/17 times x. So now this is a different type of problem because we actually have a fraction multiplied times a variable. So notice that the variable is almost isolated. The only thing that's in our way is the 5 over 17. So the standard way to get rid of a fraction that's multiplied times your variable, once you have your variable on one side like this, is to multiply by the reciprocal. Okay? Multiply both sides by the reciprocal. Multiply both sides by the reciprocal. And the reciprocal just means you flip over the fraction. So here, the reciprocal of 5 over 17 is going to be 17 over 5. Okay, so we're actually going to multiply both sides of the equation by 17 over 5. And you might be wondering, well, why do we multiply by the reciprocal? What does that do? Well, notice on the right side, because we have a 17 on the top and the bottom, those 17s cancel out. And then we also have a 5 on the top and the bottom, so those 5s cancel out. So on the right side now, we just have x. So we've isolated the variable x, and then the only part that's a little bit challenging is the left side. So remember that if they write a number like negative 25 and they don't write the denominator is automatically 1. Okay, so this denominator here is actually 1. And then how do you multiply fractions? You multiply them straight across. Okay, but before we multiply these, I notice that I have a 25 up here and a 5 down there. So I can actually simplify this by dividing the top and the bottom by 5. Okay? So if I divide the top, which is the 25, and the bottom, which is 5, if I divide both of those by 5, we're going to get 17 times negative 5 on the top. 17 times negative 5 on the top. And then on the bottom, 5 divided by 5 is 1. So now on the bottom we just have 1 times 1, which is 1. Okay? So then what's 17 times 5? Well, 5 times 7 is 35. Carry the 3. 5 times 1 is 5, plus 3 is 8. So you're actually going to get negative 85. Okay, so we get x equals negative 85. And if you're not good at doing things like 17 times 5 in your head, you can, of course, always use your calculator, whether it's a real one or the virtual calculator, just to make sure that 17 times 5 is 85. Okay? So negative 85 is our answer. All right. Okay, so that was number 5. Let's take a look at number 6. I'm going to be doing a lot of examples to make sure you learn how to do each type of problem. Okay, so number 6 is negative 5 over 9 times m equals negative 1/2. A negative 5 over 9 times m equals negative 1/2. So once again in this problem, we can see that the term involving the variable is by itself. So the only thing in our way is the negative 5/9. So since it's negative 5/9 times m, just like with the last problem, we're going to multiply both sides by the reciprocal of negative 5/9. But the thing is, because it's a negative, the reciprocal is also going to be negative. Okay, so the reciprocal of negative 5/9 means we flip it over, but it's still negative. So the reciprocal of negative 5/9 is negative 9/5. Okay, so we multiply both sides by negative 9/5. So reciprocal means you flip it over, but if the original number was negative, this is still going to need to be negative. Sorry, my mouse is messing up right now. Okay, there we go. Alright, so the reciprocal, if the original number is negative, the reciprocal is also negative. So on the left side, just like before, if you multiply with the reciprocal, the 9's cancel and the 5's cancel. And then also, because there's two minuses, remember 2 minuses makes a plus when you're multiplying or dividing. So those are going to cancel out. So on the left side, we're just going to have m. And then on the right side, the minuses also cancel out there because there's 2 of them. And then remember, you multiply fractions straight across. And because there's no common factors here, there's nothing to divide by, so we just multiply. So we got 1 times 9 is 9 on the top, and then on the bottom, 2 times 5 is 10. So our answer is m equals 9/10. So a lot of these early problems aren't that hard if you know what to do. They're only really challenging if you're not sure what to do. Okay, so let's take a look at problem number 7. Okay, problem number 7 is negative 3m equals negative 9/8. Negative 3m equals negative 9/8. Alright, so this one is pretty similar to the last problem. It's just there's a special trick that you might not know about, so that's what I'm going to cover here. So on the left side, we're trying to get rid of a negative 3 so that we can isolate m. But in order to do that, notice that this isn't a fraction. So if it's not a fraction, what's the denominator? Remember, if they don't write the denominator is automatically 1. Okay, so this negative 3m is actually the same as negative 3/1 times m. And that's the main trick to this problem, is remembering that if they don't write the denominator is automatically 1. Okay, and then for the rest of the problem, it's just the same as the last problem. Okay, so to get rid of the negative 3/1m, we need to multiply both sides by the reciprocal of negative 3/1. So in other words, we flip it over. So instead of being negative 3/1, now it's going to be negative 1/3. So we're going to multiply both sides by negative 1/3. Okay, so on the left side, the negatives cancel and the 3's cancel, and we just get m. And then on the right side, the minuses cancel, and we can simplify. So the 9 and the 3 can both be divided by 3. So we're going to divide the 9 and the 3 on the top and the bottom by 3 to simplify it. So 9 divided by 3 on the top gives us 3. And then on the bottom, 3 divided by 3 is 1. So we actually have 3 times 1 over 8 times 1. So on the top, we just have a 3, and then on the bottom, we have an 8. So our answer is m equals 3/8. M equals 3/8. Okay, so I know it seems like a lot of examples. It is a lot of examples, but I want to make sure you guys get solid on all this because a lot of people struggle with equations with fractions. So I wanted to cover pretty much every case. So problem number 8 is next. So for problem number 8, we have x over 4 plus 2 equals 11 over 4. X over 4 plus 2 equals 11 over 4. So now, probably the easiest way to do this is, since we have a fraction for the variable, we're going to isolate the fraction for the variable first. So we're going to have to get rid of the 2. But remember that 2, if they don't write the denominator is automatically 1. So this is actually 2 over 1. So what we want to do is we want to get rid of the 2 over 1, and we want to combine it with the 11 over 4. But we notice they have different denominators, so we're going to have to build these so that they have the same denominator. So here we have a 1, there we have a 4. So here we're missing a 4. So we're going to multiply this fraction by 4 on the top and the bottom. Okay, so we're going to multiply by 4 on the top and the bottom. And that's going to give us 4 times 2 is 8 over 4 times 1 is 4. So we have x over 4 plus 8 over 4 equals 11 over 4. Alright, and now that we have built them to the same denominator, now we can go ahead and move the 8 over 4 to the right side. Okay, so we're going to go ahead and subtract 8 over 4 from both sides. So if I minus 8 over 4 from both sides, on the right side, we can see that because we have the same denominator, we're just going to be subtracting the numerators. Okay, so we're going to have 11 minus 8 is 3 over 4. So we actually get x over 4 equals 11 minus 8 is 3 over 4. Alright, and then to finish the problem, we have to get rid of this 4 in the denominator. So how are we going to do that? Once again, you can multiply both sides by the reciprocal, but you might not be sure what the original fraction is here. So remember, the coefficient of x, if they don't write it, the coefficient of x is 1. Okay, so we actually have 1x over 4. That's our fraction on the left side. And we want to multiply both sides by the reciprocal. So reciprocal means you flip it over. So instead of 1 over 4, we're going to be multiplying both sides by 4 over 1. Okay, so we multiply both sides by 4 over 1. So on the left side, the 4's cancel, and we just get x. Okay, and then on the right side, the 4's also cancel. So we get 3 over 1, which is 3. So on the right side, we get our answer is x equals 3. Alright? Alright, so our answer is 3. Okay, that was problem number 8. Okay, I know it's getting to be a lot of problems, but I want to keep going. So problem number 9 is k over 5 minus k equals 8. K over 5 minus k equals 8. So this is a new type of problem where we actually have two terms involving the variable, and one of them actually has a fraction. So what you're going to have to do here is you want to combine like terms on the left side, but in order to do that, you're going to have to build these to the same denominator. And what's the denominator for the negative k if they don't write it? Well, hopefully you remember if they don't write the denominator, it's automatically 1. Okay, so that's actually negative k over 1. Okay, and we want to multiply this fraction by what we're missing. Okay, we want these to have the same denominator. So here we have a 5, here we don't. So here we're going to multiply the second fraction by 5 on the top and the bottom. Multiply the top and the bottom by 5. Okay? Alright, so what's that going to give us? Well, on the left side, now we're going to have k over 5 minus 5k over 5 equals 8. Okay, and then for the 5k over 5, this has the same denominator as k over 5. So what this actually means is we get to keep the denominator and then we subtract the numerators. Okay, so it's actually going to be k minus 5k on the top, all over 5, equals 8. Okay? And then on the top, k minus 5k is negative 4k. Okay, because 1 minus 5 is negative 4. So we actually have negative 4k over 5 equals 8. All right, so now we have it, so there's just one variable left on the left side. But we have to get rid of the negative 4/5. So to get rid of negative 4/5, we're going to have to multiply both sides by the reciprocal. And to do that properly on the right side, we need to write 8 as 8 over 1. Because remember, automatically the denominator is 1 if they don't write it. Okay, and then we're going to multiply both sides by the reciprocal of negative 4 over 5, which means we just flip it over. So we multiply both sides by negative 5 over 4. Okay, we multiply both sides by negative 5 over 4. So on the left side, the negatives cancel, the 4's cancel, and the 5's cancel. So we get k. And then on the right side, we have 1 minus, so we know that our answer is going to be negative. And then we can divide 8 and 4 by a common factor of 4. Okay, so we're going to divide the 8 and the 4 by 4. So on the top, we're going to have 8 divided by 4 is 2. So we have 2 times 5 on the top. And then on the bottom, 4 divided by 4 is 1. So we have negative 2 times 5 on the top and 1 times 1 on the bottom. Okay, so negative 2 times 5 is negative 10 over 1 is negative 10. So we get k equals negative 10. All right, so negative 10 is our answer. All right, that's a lot of examples. We're still not done. All right, so we've just got 2 more examples from this section. So we're going to have a total of 11 examples. So this next one is number 10. So for number 10, we have x over 5 equals x over 7 minus 6. X over 5 equals x over 7 minus 6. Alright, so the new thing here is we actually have a variable on both sides, and each side has a different fraction, so it has a different denominator. So what you're supposed to do here is you're supposed to build these fractions so that they have the same denominator. So we're going to have to find the LCD of 7 and 5. So let's do that first. So the LCD of 7 and 5, well, they don't have any common factors. 7 and 5 don't have any common factors. So probably the easiest way to find the LCD if you don't have any common factors is to just multiply. Okay, so you just multiply. So 7 times 5 is 35, and that's actually going to be the LCD. Okay, so 7 times 5 equals 35. Again, the reason we just multiply is 7 and 5 don't have any common factors. So if two numbers don't have any common factors, the LCD is the product of the two numbers, so you multiply the two numbers. All right, so what we're going to be building to here is we want to build each denominator to 35. Build each denominator to 35. So on the left side, we have a 5, and we want to have a 35. So we're going to multiply by what we're missing. Well, 5 times 7 is 35, so we're going to multiply this fraction by 7 on the top and the bottom. Okay, and then on the right side, we have x over 7. Here, 7 times 5 is 35, so we're missing a 5. So on the right side, we're going to multiply the top and the bottom by 5. Okay? So after we do all that, we're going to end up with 7x over 35 on the left side. And then on the right side, we have 5x over 35 minus 6. Now you don't need to build the 6 to 35 because it's not going to be combining with the x's. But I did have to build the x's to the same denominator because they're like terms. And in order to combine them, they have to have the same denominator. So that's why I only built these two to 35, but not this one. Okay, so to finish this problem, we need to get all the x's on one side. And like I said, if you have a variable on both sides, it's usually easier to get rid of whatever coefficient is smaller. So 5 over 35 is smaller than 7 over 35, so we're actually going to get rid of this one because it's smaller. So what's the opposite of adding 5x over 35? Subtracting 5x over 35. So we're going to minus 5x over 35 from both sides. Okay, so on the left side, 7x minus 5x is 2x over 35. And then on the right side, all we're left with is negative 6. Right, because these cancel out. Alright, so we have 2x over 35 equals negative 6. And then to finish the problem, we have to isolate x on the left side. So the way we do that is we need to multiply both sides by the reciprocal of 2 over 35. And remember, reciprocal just means you flip it over. So we're going to multiply both sides by 35 over 2. Okay? And on the right side, remember that if they don't write the denominator for negative 6, it's automatically 1. So on the right side, we actually have negative 6 over 1. And we're going to be multiplying both sides by 35 over 2. Okay, so on the left side, we can see that the 35s and the 2's cancel out. So we just get x, which is what we wanted. And then on the right side, we do have a common factor. For the 6 and the 2, we can divide each of those by 2. So we're going to divide the 6 by 2 on the top and divide the 2 by 2 on the bottom. Alright, so that's going to give us, on the top we have 35 times 6 divided by 2 is 3, so 35 times negative 3, all over 2 divided by 2 is 1, so we have 1 times 1 on the bottom. Okay, and then what's 35 times negative 3? Well, 3 times 5 is 15, and 3 times 3 is 9. So that should be 105. or you can just use your calculator. But either way, you should get x equals negative 105. Okay. And again, I'm not checking any of these. If you wanted to check this, though, it would be quite a bit of work to plug it back in. So that's why I don't bother to check them, because it's just so much extra work. Okay, so I just wanted to do one more harder problem. This is probably the hardest one in the whole section. So for this one, we have 3 different fractions. All right, so this is example number 11. We have 3 different fractions. 3 over 7 minus x over 4 equals 5 over 28. 3 over 7 minus x over 4 equals 5 over 28. So what we've got to do here is, since everything has a fraction, we have to build all of these fractions so that they have the same denominator. Okay? So we need to find the LCD of 7, 4, and 28. But fortunately, the biggest number is 28. So if we list the multiples of 28, we actually get lucky. Because if I write 28, we know that 7 goes into 28, and 4 also goes into 28. So actually 28 is the LCD. Okay, so it's not quite as hard as it looks. So since the LCD is 28, we need to build each of these denominators until they're all 28. So looking at this first fraction, we have a 7 in the denominator. We need to multiply by what we're missing so that we get 28. So we're going to multiply this first fraction by 4 on the top and the bottom, because 4 times 7 is 28. Now in the second fraction, we're missing a 7, because 4 times 7 is 28. So we're going to multiply the second fraction by 7 on the top and the bottom. Okay? And then on the right side, we already have 28, so we don't need to multiply by anything. Okay, so after we do all that, on the left side, 4 times 3 is 12 over 28. So we have 12 over 28 minus 7x over 28 equals 5 over 28. Okay? And then you can actually do a nice trick here. Because every single fraction has exactly the same denominator, probably the easiest way to finish the problem now is to multiply everything by the denominator. Okay, so multiply both sides. Multiply both sides by 28, which is actually our LCD. So why is that a good idea here? Well, because we actually built all the fractions to 28, we can now multiply both sides by 28, and all the 28s are going to cancel out. Because on the left side, you have a 28 for both denominators, so those 28s cancel out. And then on the right side, the 28s also cancel out. Okay, so we actually get 12 minus 7x equals 5. 12 minus 7x equals 5. So the advantage of doing it this way is it gets rid of all the fractions. It is a lot of work, but it's kind of easy once you get rid of all the fractions, because now this is easy to solve. So what we can do here is we can subtract 12 from both sides. Okay, so we're trying to isolate x on the left side. So to get rid of the positive 12, we're going to subtract 12 from both sides. Okay, so that's going to give us negative 7x equals 5 minus 12, which is negative 7. And then we can divide both sides by negative 7. Okay, and if we divide both sides by negative 7, the negative 7s on the left side cancel out, and they do on the right side as well. So the pluses and the 7s the minuses and the 7s cancel out, and that just gives you positive 1. Okay, so our answer is x equals positive 1. And that's it. That's the hardest problem in the section.